Okay, so we've now got our system for finding matches on our board. So it's now time for us to start doing things with that information that we have. So one thing we want to do first is we want to make it so that our players can't just move gems all over the grid. So at the moment, I can just click and drag this guy around. I can move any of these to whatever position I want, so I can make whatever matches I want to just by allowing you to move any of these objects around. And that's not really great. What we want to have happen is if your player moves the object, if there is a match, the object can stay there, but if there's not a match, then it will return to its original position. So let's stop that running here. What we're going to do then is go back into our gem script, and obviously if we want our objects to be able to return to a position they were at after we don't have a match, we need a value for that. So here I'm going to have a public vector2 int that we're going to call previous position. Now the reason I'm using a public version of this is because we obviously want, if we have two gems that are beside each other, whenever they move, we have to make sure that they keep track of where they were previously in case we want to move them back. So with that in mind, I'm going to hide it in the inspector because it's not something we actually need to change in Unity, but we want it to be publicly available. So what we're then going to do is, first thing we're going to do is when we move, so when we call our move pieces, right before we move anything, we're going to say our previous position is equal to a new vector2 int. Wait, no, what am I doing? A new vector2. Our previous position is equal to whatever our position index currently is. So before we move our object, then we're going to say that it is that. And then after we move, this is when we want to check if our objects are in position. Now, one thing to note, of course, is that, hey, when we move, our gems visually don't actually change position instantly. They take like a little bit of time to move into position. So we want to have it so that our gem moves into position and then it does the check to see if it should stay there, and then it moves back if it's not in the correct position. So what we're going to do is we're going to create something down below here called a coroutine. So a coroutine basically runs on a separate state of time, and we'll talk about that in a second after we create it. But how we create it is we say public I enumerator, and we're going to call this the check move co. So check move coroutine. And then how we're going to call it is here in our move pieces, at the end after we move into our position, we're going to say start coroutine check move co, and then our open close brackets and then our semicolon. So what is a coroutine and why is it different than just a normal function? Well, a coroutine basically happens in a different execution order. So if I just let's just get a new little paint here. So normally you have your normal progression of time in Unity. So you have something, let's say you have a function and you have, well actually it's probably easier just to see with an example here. So when we have our on mouse down, that's grand. When we release a mouse, we're in our update loop, and we know update happens constantly over and over and over again every single frame. So what happens is it goes through this list, and let's say there hasn't been a mouse press. It goes through this, it tries to move our object, that's fine. If there's been no mouse press, it gets to the end of the update, and that's it. And then it goes, okay, let's come back around for the next update, and it goes along and keeps doing that over and over and over again. But if there is a mouse press, what'll happen is it'll go to here, it'll do this little bit, and then it'll go to this function, and okay, I want to calculate my angle. So it goes down to calculate angle, it does all of this stuff, then it goes to move pieces. We are moving. We get to move pieces, and it'll say, okay, I'm going to move pieces, so I'll go through all of this stuff here. Let's ignore this coroutine for now, and it'll get to the end. Once it gets to the end, it says, okay, my move pieces is done, so go back up here. Move pieces is finished, so we'll continue on to here. Okay, our calculate angle is done, so we'll go back up to here, and we go to calculate angle, and it'll say, okay, I'm done, so continue on, and it'll get to the end of update, and then that'll be fine. It'll continue on back to the normal schedule of things. But a coroutine is handled completely different. So once we get down to the point here again, we go to our move pieces, we get to our coroutine, and our coroutine starts, and basically on the CPU of your computer, you have multiple cores always working and working. Unity in general is only working on one core of your CPU at a time. So say you have 8 cores in your CPU, it's using one to do all its logic. But a coroutine will basically say, oh hey, I'm going to run on a different core now. So basically what will happen is it'll get to this point and it'll say, okay, start this coroutine. Okay, I'm going to start this coroutine. It's going to move on to a different core, and I'm also at the same time going to keep running this function. So as soon as it starts this, it also goes, okay, I've done this, now continue on here, back to my update, and at the same time, this function will also be running in the background. And because this is running in its own little schedule, it needs to know when it should happen and when it should do things, and basically when it should stop. So you can see right now we've got this red underline on here, and that's because it wants some information about what it should be doing and how long it should have this coroutine happening for. So within this coroutine, we're going to add something called a yield return new wait for seconds. And in a bracket here, we're going to say 0.5f. So what is going on here? Well, basically what's happened is a yield basically means it is telling the coroutine to wait for something to be returned. Return is basically a value that's being sent back to the coroutine itself. And what we're waiting for is a wait for seconds routine to happen. Wait for seconds basically takes in a value, we're telling it to wait for half a second, and then you're allowed to continue being a coroutine basically. So the handy part of this is we can tell it we're going to start our coroutine to check the move. It's going to wait for 0.5 of a second, and then we're going to do some code to check if a match has occurred, and if it hasn't, then we'll move back. So basically now we're saying we're going to wait, the little half a second wait is going to be enough for our gems to move into position, and then we're going to check for a match, and if there isn't a match, then we move back. So in here, we're going to say after our wait for seconds, then we're going to tell the board dot match. Oh, I didn't make that public. Did I not make that public on our board? There we go. Okay, that should be public so that our gems can access it. And we're going to hide that in inspector because again, we don't need to see it. Let's go back in here. So board dot match find all matches. We're just going to double check that all the matches have been checked at this point. And then we're going to say, okay, so we've done a move. We know that when we moved, where's our move function? Here we go. Our move pieces, we moved ourselves and we also moved the other gem. So we want to make sure, first of all, that the other gem that we moved isn't currently empty. So if other gem, so basically it hasn't been destroyed when it got moved. So if other gem is not equal to null, we want to make sure that that's true because we don't want to have any errors happening. And then we're going to check and see, we've done our matches check. So if we are not matched, so if we put an exclamation mark means not basically. So our bool for is matched can be either true or false. So if we are not matched and the other gem is not matched, because remember when you swipe something, if we just play this here, when you swipe something, so for example we have our red and our purple one here, I'm going to swipe the red one up, so that will create a match with the purple one, but it won't create a match with the red one, which is the, in our script here, that would be the is matched we're looking at. So we want to make sure that either of the gems that we have just moved are matched. So if neither of them are matched, well then hey, we need to go back to our previous positions because we haven't found a match. So we're going to say here, if we're not matched, then the other gem should go to where we currently are. So other gem dot position index should be equal to our position index. And then our position index, we're going to say our position index should be equal to whatever the previous position is that we stored. So I just realized I made that previous position a public variable because I think I had this one confused earlier with the board one that we made private. We don't need that to be public because we're not accessing that on the other gem. We're going to have that be private because we're only using it ourselves. So now we've got the other gem has gone to whatever position we're currently at, and our position is going to be wherever our previous position was. And now that we've done that, you should remember that in our move pieces, when we move them, we assign the board to we assign their positions on the board to be the correct ones. So we need to do the same thing now because we've switched them back. So I'm just going to copy this line of code and paste it in there like so. And then for the time being, that's it. We're not doing anything else with the matches just yet. But for now, we basically have this in place. So now they will swap back into their correct position. So let's go back in here and see that in action now. So once it compiles, we can press play. And if I swap these ones, oh, they didn't go back into position for some reason. Well, he's not matched and he's not matched. Okay, so what's going on here? Why is that not? Oh, I didn't make this not. There we go. That should be not is matched. If we're not matched and the other gem isn't matched, then do this stuff. So it wasn't, as far as it was concerned, the other gem wasn't fulfilling that part of the deal. So if I swap these now, there we go. Now they pop back into position. If I swap this one down, they won't pop back because the yellow got matched. There we go. That one won't get matched. If I break these ones, well, they're already marked as matched. So we're obviously getting a bit of a strange situation here. They were already marked as matched, so that's why they didn't pop back. If I do that one, there we go. They pop back into position. Obviously, when we have a match like this, we're going to be destroying them. So this is not a situation the player will run into. But it's good to see that our matching system is working correctly. When they're not matched, they pop back. And when they are matched, they stay in the correct position. So perfect. We now have our gems moving back when we don't want them to stay there.